Now notice for all of these, you have to be able to write the correct chemical formula. They don't give it to you. Now, these are all represent various types of chemical reactions. In a few weeks, you'll be learning the 5 basic types of chemical reactions. So I'll go ahead and rattle off the type of reaction it is, but it's incidental to what we're doing here. Aluminum nitrate reacts with sodium hydroxide to form aluminum hydroxide and sodium nitrate. This is called a double replacement reaction. Aluminum nitrate plus sodium hydroxide. Now leave yourself plenty of room to write coefficients as needed. Produces aluminum hydroxide and sodium nitrate. Now remember, one of the hints was that in the notes was that if a polyatomic ion remains intact, then treat it as one thing. So you have nitrate here and you have nitrate over here. So rather than breaking it apart into nitrogen and oxygen, just treat it as one thing. And the same thing with hydroxide. You have 3 hydroxides here, you have 1 hydroxide here. So just treat it as one thing. It makes it much easier. All right, let's look at the nitrates first. So you have 3 nitrates here. So to balance the nitrates, I would need to put a 3 in front here. That'll give me 3 sodiums. So to balance the sodiums, I would put a 3 here, which would give me 3 hydroxides, which is what I have here. And I have 1 aluminum here, 1 aluminum here, and so that is a balanced equation. Next, this is a decomposition reaction. Potassium chlorate produces potassium chloride and oxygen. So potassium chlorate produces potassium chloride and oxygen. Oxygen diatomic. Okay, now notice that you have 3 oxygens on this side and 2 oxygens on this side. So you have kind of an odd-even conundrum. So when you have that, think least common multiple. So if I put a 2 in front here, that'll give me 6 oxygens. And if I put a 3 in front here, that'll give me 6 oxygens, 6 the least common multiple. Okay, now when I put the 2 in front of the potassium chloride, it also doubled the number of potassiums and chlorines, and I can easily take care of that by putting in a 2 here. So that's our balanced chemical equation. Next, phosphoric acid and magnesium hydroxide produces magnesium phosphate in water. This also is a double replacement reaction. More specifically, it's a neutralization reaction, an acid reacting with a base to form water and an ionic compound, or what we say is a salt. Phosphoric acid, H3PO4 plus magnesium hydroxide produces magnesium phosphate and water. All right, so let's look at the phosphates first. You have 2 phosphates here, 1 phosphate here. So if I put a 2 in front here, that'll balance the phosphates. Now that's going to give me 6 hydrogens, but before I jump over here to start balancing the hydrogens, you need to notice that you also have hydrogens here, the magnesium hydroxide. And the hydroxide, even though it is a polyatomic ion, no longer exists. It's not as a product. So we need to look at the hydrogen and the oxygen separately. So let's leave the hydrogens and oxygens for a minute and look at the magnesium. You have 3 magnesiums here. So to balance the magnesiums, I would need to put a 3 in front here. Okay, so now let's look at the hydrogens. You have 6 hydrogens here, and you have 6 hydrogens here. You have 2 hydrogens just in the formula itself, and then with the 3 in front, that triples everything, so you have 6 hydrogens. So 6 hydrogens plus 6 hydrogens gives me 12 hydrogens on the reactant side, so I need 12 hydrogens on the product side. So I need to put a 6 here. Now, that'll give me 6 oxygens and 8 oxygens on the product side. So it's a total of 14 oxygens, 6 from the water, 8 from the magnesium phosphate. So I have 14 oxygens on this side. So on this side, I need to have 14 oxygens as well. So 2 times 4 gives me 8 oxygens here, plus 3 times 2 gives me 6 oxygens, so that's 8 plus 6, 14 oxygens. So everything balances. We're good to go. Next, another decomposition reaction, ammonium nitrite. Produces nitrogen diatomic plus water. Now you have 2 nitrogens here, and notice you already have 2 nitrogens in the ammonium nitrate, so the nitrogens are good. You have 4 hydrogens, so over on this side to have 4 hydrogens, I would need to put a 2 here, which gives me 2 oxygens, which is what I have here. So that's all I needed to balance this equation was that 2. So that's good. Okay, and last, ammonia and oxygen produces nitrogen monoxide and water. Okay, this is also a combustion reaction. Did I mention a combustion reaction? I guess I haven't. This is a combustion reaction. Okay, ammonia, NH3, plus oxygen, O2, to produce nitrogen monoxide and water. Now we're going to have to play around with this one a little bit. Okay, first let's look at the hydrogens and do as we did above. Least common multiple would be 6. So if I put a 3 here, I'm sorry, a 2 here, and a 3 here, that'll give me the 6 hydrogens on both sides. Now I have the 2 there, means I have 2 nitrogens, so I need to put a 2 over here for the nitrogens. So everything is balanced except for the oxygens, but we're going to have a little bit of a problem here. You have 2 oxygens here, 3 oxygens here, so you have 5 oxygens on this side, and any number that you put in front of here is not going to give you an odd number. So remember the last hint in the notes was, well, the second to the last. What was it the last? I can't remember. If you have a diatomic element and everything that won't seem to balance, the simple fix is to double all the other coefficients. So if I just go back and make this a 4, make this a 4, and make this a 6, we can now balance the oxygen. On the product side, I have 4 oxygens plus 6 oxygens. That gives me 10 oxygens, which means that I can get 10 oxygens by putting in a 5 here. Now don't have an equation looking like that. When you do that kind of thing, clean it up. So let's rewrite it. 4 ammonias plus 5 oxygens produce 4 nitrogen monoxide plus 6 waters. And that is a balanced equation. All right, that's it. You have a number of these to do in your homework. Please review the notes and practice the PhET simulation. If you haven't done that already, it's a good kind of fun practice. Again, many of you are going to have problems just writing the chemical formulas. So you might need to revisit what we did earlier in the year. Remember that on my website, not on Google Classroom, but on my Weebly website, you can go to previous units and look at the unit on ionic compounds, covalent compounds, and that there's all kinds of practice there for you. All right, that's it.